Massimo is a mechanical engineer who graduated from the Politecnico di Milano in Italy and has been working in testing for more than 20 years. His career started in an accelerometers calibration laboratory, continued with shaker testing, data logging, data analysis, and then condition monitoring. He joined Meggitt in 2010 as an Indevco applications engineer. He went on to become regional sales manager, responsible for the European distribution of its test and measurement products. He's now responsible for the EMEA market of the new Meggitt high temperature product line. Hello, Massimo. Thanks for coming and preparing this presentation for us.
Thank you, Ben. It's a pleasure to join you guys. I shall say good morning or good evening, depends on the part of the world. We have a number of attendees all over around. So let's start with the presentation.
Okay. 1 second, Massimo. Sorry, let me just interrupt you. I just want to say to anybody that's watching this live, if you do have questions while Massimo is giving the presentation, then please do submit them via the window, via the right-hand side of your screen. I'll then ask him the questions after he's concluded his presentation. So there you go, Massimo. Thank you. Over to you.
Thank you, Ben. So, as stated by Ben, my name is Massimo Ravazzini. I'm the regional sales manager for EMEA area, Meggitt high temperature product line. And today we are going to have a little webinar regarding our portfolio, our production, the capabilities of our group, the technologies that we are using, the research and development units and the monitoring units that we do manufacture, some cables and accessories, few applications, what to expect within the year as new products coming out, and how to navigate our website, as Meggitt is quite a complex company, a constellation of application and products, so sometimes is not that accessible to information that easily. A little wrap up at the end of the webinar to get the key points to bring home, let's say. Let's start with the capabilities. As high temperature products, we are a little group, about 60 people, 60 workers, with a strong legacy that comes from the past. From the 70s, for instance, we were the first company as Meggitt introducing the 482 piezoelectric crystal to be mounted on a sensor. In the 80s, we were the first tourmaline sensor developed capable of 1400 Fahrenheit and 760 Celsius. 2 years ago, we came out with the highest temperature sensor ever developed by our own, and still probably unmatched with 815 Celsius temperature capability. We are well known as a company to be a leading provider of solutions for extreme environments. That was our motto some years ago, still is for demanding aerospace and nuclear and gas turbine applications. In general, our units, accelerometer or pressure sensors, are well known to be reliable in time, have a long MTBF, to be small, have a good figure of merit, and so on. Key application that we serve right now is gas turbine research and development for components testing, combustion chambers measurement, nuclear application, so within the radiation area, and of course, general research and development for temperature applications. Let's see, go next. Okay, I divided here our portfolio in 3 main categories according the higher temperature limit every unit can reach. So we have a number of units, single-ended, single axis, or differential single axis, that can reach out to 900 Fahrenheit, 482 Celsius. We did introduce I guess 9 years ago, the 2280, which was a triaxial unit, single-ended, capable for the same temperature limit in use for case vibration, basically on a turbine. Up to 1200 Fahrenheit or 650 Celsius, we have a number of units, some from legacy, the M70, M71, 6237, some tourmaline units still, the M10 and M11, and then a number of other units, even included the 2278 that was launched last year, which is a single-ended triaxial unit, pretty unique to be able to be working at 650 Celsius. And of course, as said before, the 6245, which is a single-ended, single-axis, unmatched sensor, 815 Celsius or 1500 Fahrenheit. Okay, about the technology that we are using, well, not a real secret. These are charge units. I mean, to go such a high temperature, you need a crystal. Crystal, then, when it's subjected to strains, thanks to a seismic mass, which is attached to it, well, it's suffering some strains. The strains have the consequence to polarize the crystal stack itself. So we can pick up the charge, the resulting charge, according to the acceleration which it is subjected, the unit is subjected to, and then we can measure the acceleration. This is not a secret. Our design is compression or shear mode. These are pretty much in use for high frequency application. That means that the units need movement. We cannot measure extreme low frequency. Otherwise, we do not have, we have an uneven distribution of charge inside the crystal. As well, we cannot use them for shock application, as residual stress is actually inducing an offset in the measurement, so measurement errors. Regarding pressure application, pressure unit, here we go. We do have the same concept of using a compression design placed on the tip of the unit. This is a wall mount unit, basically. Which is providing the strain to the crystal, and then we can measure the pressure applied to the crystal itself, to the membrane of the sensor itself. This kind of unit do feature an integral cable. They are capable to withstand 538 Celsius as the same stable and continuous monitoring application, or we do define a transient period of half an hour to use this unit as well as 650 Celsius. Well, these units are, as the accelerometer, in use for dynamic application, so dynamic pressure measurement. Let's go to see our little, exactly. These are the most common units that we design, that we manufacture, and we sell to customers nowadays. The 522 series, which is coming with a number of variety, a number of models, sub-models, but these are the most common in use. Typically for humming and for combustion chamber application. 538 is the maximum temperature, or 650 in case of intermittent temperature. The sensitivity is 12 or 17 picocoulomb per psi. And yeah, we do also have the M35A, which is an ATEX version of this pressure unit. Let's go for the next one. Let's go back now to accelerometers for research and development and monitoring units. The first couple of models are probably quite well known to our customer, probably to our audience as well, because they are coming from our legacy, from our history. The 2273 AM1 or the 2276 accelerometer are, let's say, not really general purpose, but very common high temperature application accelerometer in use worldwide. They can reach out to 482 Celsius in the case of the 2276 or 400 Celsius in case of the other model 2273 AM1. The main feature and Now, I mean, we are selling these units mostly for nuclear application. In fact, one of the main features is the very good resistance to integrated gamma flux or an integrated neutral flux, which you are actually finding into the radiation area of a nuclear power plant. Next one is the 2278, associated now with the 3076A cable. We have a look afterwards about this cable. This is a triaxial unit that was introduced last year. It features very good sensitivity, nominal sensitivity of 4 picocoulomb per G for each of the channels. In fact, it's a triaxial unit, but basically is a 3 different sensor into a matrix. Can work constantly at 650 Celsius. This is the main advantage. It's also featuring the same footprint of our bestseller 6233C unit to bolt mount. That's quite extraordinary for the size, and for the weight is only 55 grams. Very good one. This model, the 6237 M70 and M71 series, is also coming from our history, it's a legacy product. It has incredible, it's a very good, outstanding, I would say, sensitivity, nominal sensitivity of 10 picocoulomb per G at 650 Celsius. It's pretty unusual to have this kind of sensitivity even from our competition. Let's say this is a very reliable unit. It has a integral cable. It's a hardline cable, and has a unique characteristic that was, let's say, solved with the next unit, the 6243M series. It's in fact, in particular, the 6243 and 6245, these are actually solving the previous model, let's say, characteristic that was not always desirable. That is the susceptibility to pyrospiking or thermal spiking effect. These two units that were introduced 4 years ago in a variety of models. I mean, we have different sensitive axis, differential or single-ended. We may have integral cable or even welded cable. Do not suffer this type of effect. Let's say the benefit of this feature is visible on the next slide, in which we have a plot, a time history of an acceleration for 15 minutes, in which we have the top plot, which is an acceleration time history, and at the bottom we have a velocity time history, so we have an integration of the signal. What is happening when the pyrospiking effect occurs is actually we do have residual charges moving inside the crystal that are bringing up the noise problem. Basically, this is what happening. This is this is usually happening during cooling sessions of a testing or a turbine cooling down. Next one, 6243 M8 M9 is another version of the previous 6243M series, in which we do provide a welded cable, a little sensor on the top, which has the same figure of the previous one, and we have a cable 3076 in this case, so it can withstand 538 Celsius degrees. Yeah, sensitivity is 5.5 picocoulomb per G, resonance frequency 11 kHz. It's a pretty good unit, and is not pyrospiking. So this is the main benefit of this one too. We are also considering to implement the 3076A cable in this family to have the unit capable to work constantly at 650 Celsius as well. Let's see the next one. Should we need to push the temperature limit higher, we can provide some isolation plates the isolation material can withstand temperature for a higher temperature for a limited time frame, let's say half an hour. In this case, in this example, a customer was asking actually to be able to measure 220 Celsius plus the limit of the sensor itself, and we were able to provide this solution. The thickness of the plate can be adjustable within certain limits, of course, and as well is not introducing a relevant error in the measurement. It's about should be about 1% increase of the deviation, so it can be acceptable for this kind of measurement. Some other units. These are for monitoring application, for permanent monitoring application. The one on the left, the 6235M1, this is pretty in use, pretty much a lot in use in the nuclear power plants. It has the typical resistance to radiation that we feature, gamma flux 6.2 at times 10 at the power of 10 radiation. Rad and integrated neutron flux as well, 3.7 at 10 at power of 18 Newton per square centimeter. It's quite neutron, sorry, not Newton. And the other one is instead one of our bestseller, the 6233C, which is typical for MRO application. We have a specific slide afterwards. It features the A-ring 3-points mount, very long MTBF. It's the C version, so it's actually the 4th generation of these. It's a very long and very stable unit. We have 1,000 of channels installed of this type, and for aerospace application, typically up to 482 Celsius operations. This one comes with the 3 different sensitivities, which are 10, 50, or 100 picocoulomb per G. Next, we do have. This is a permanent mounted unit that we design for specific customers. Basically, it comes with a variety of cable length or connectors. It is not designed to break any particular record, but to be reliable up to 20 years of continuous operation. Even from here is listed -54, but usually it's around 480, 500 Celsius operation. So very resistant. So the application for this one is the classical absolute vibration monitoring of a gas turbine. Nothing to add in this. Okay, for cable and accessories, we do have we do manufacture in our plant in Irvine differential or single-ended cable. Here I listed the 3 models of the single-ended cables. So the 3075 M6, which comes from Legacy as well, single-ended unit, hardline. On the other side of the slide, 3076 and 3076A, which were recently introduced a couple of years ago, and in particular 3076A last year, which are capable for higher temperature limit. The 3076 up to 538 is 1000 Fahrenheit, and the other one, the 3076A, up to 1200 Fahrenheit, 650 Celsius. These are soft line cables. The benefit of soft line cables are multiple. They are lighter. They have a much better bending radius. It's 3 times more than the 3075 M6 model. They do not suffer fatigue while bent, and as well they are not providing additional strain into the system, into the measurement system, because of the flexibility of the cable itself. Going for differentials, we do have model 6918 M30 and 2001. In particular, the first one is in use for a differential unit like the 6233 or even the 6243 M series 3 and 4. Can withstand up to 482 Celsius. It's a hardline magnesium oxide, cable type, and it is in use for aeronautical applications. The 2001 is a soft line unit that was recently introduced. I mean, we are introducing since March. We are launching it these weeks, basically, and that was designed to be working into nuclear environment. It has the typical resistance to radiation, and a lower temperature limit is about, I think, 200 Celsius, something like that. Let's see for the next one. Here I'm introducing the 1772 remote charge converter, which is a little piece of electronic which is capable to condition the charge signal output of a single-ended unit and make it in millivolt, basically much more easier as a signal to manage, This unit has multiple features. First, it is designed to be used with a Meggitt unit. In particular, because it's featuring TRS, it's a transducer's resonance suppression circuit, which is actually electronically it's canceling the transducer's resonance electronically. In this case, we can actually extend the usable bandwidth of our unit. That's why it is set to be working on a specific unit only. As well, it's capable to use the full temperature range of the sensor itself, because increasing the temperature, actually the sensor inner resistance is dropping. We can go from gigaohm down to kiloohms, to tens of kiloohms, basically. In this case, this unit is capable to manage the lower system impedance. And if you want to see a plot, here it's the plot. So you got these on the top part of the slide. You do have the unit classical 6243M, which is not using the remote charge converter, is using something else. In this case, the frequency, the resonance frequency is pretty much visible, and the usable frequency should be around 5% deviation, is about 3 kilohertz. Instead, with the RCC in use, we have the suppression. It's about 20 dB suppressions, and the -5 deviation is at around 6 kilohertz. So it's almost doubling the usable frequency of the unit. It's quite interesting. For the rest, should be okay. Here we go. Okay. So this is instead, well, just to complete the offering, we do have a number of cable adapters, 1032 to 1032, or 1032 to 7/16 UNS. I mean, differential cable, single-ended to differential, and vice versa. Cable adapters and mounting studs, so you can have the M8, the M4, the M5. I'm just reporting a few of them because it's just accessories, but all of them are rated to 900 Fahrenheit, so it's quite a good resistance to temperature as well. Let's go for next applications. All right, so applications, well, the first one is quite common. I was introducing this one before. It's combustion instability. Basically, we do use our unit, the 522 M17, which has certain features, maximum temperature, 1000 Fahrenheit, blah, blah, 500 PSI statics, and so on, to monitor the humming effect. So, when we have a gas instability, gas combustion instability, we may have oscillation in the pressure inside the chamber, and this may lead to severe damage of the turbine. So this effect must be monitored, and we have the unit for it. Second application is quite common for the primary circuits of a nuclear power plant. It is pipe type of vibration monitoring. Basically, what is requested here to the unit installed, it's to resist a number of years inside the radiation environment. So we need basically radiation resistance to gamma flux. This is the solution we usually provide. It's the 2273 or the 2276, which is pretty much a similar resistance. Next one. This is the application for MRO departments, for MRO test cells, when aero engines are tested for, weeks or months, and we need a reliable unit to be installed and to be left there running all the time. So stable temperature response as well. We have the 6233C unit, usually it's a 50 picocoulomb per G. A little path of the 6918 M30 cable just out of the hot area. And then we can use now the 2001 soft line cable to the signal conditioning or to the data acquisition system. The reason to use the 2001 is just for economicity. It's not useful to have a very resistant cable where there is no need to temperature. Okay. This is the aeroderivative engineering research and development. When we consider to test any type of rotating components or vibrating part, like the combustor cans of a turbine, we can use our unit, the legacy one, 6237 M70, if we do not need to integrate the signal, or when is necessary for some dynamics, integrate the signal, the 6243 M series, to avoid the pyrospike effect in this case, plus our sensor, our remote charge converter, the 1772-1 in this case for this unit. This is basically the application, R&D, research and development for turbines. Then next steps, so what to expect in the next period. We are releasing in a few months a new triaxial unit. So again, 3 independent cables, hard line coming out of a welded connector, 4 picocoulomb per G sensitivity each of the channel, capable to work constantly at 760 Celsius. This will be released quite soon in Q4 2021. The other one, it's a single-axis, single-ended unit, ultra-high temperature piezoelectric single-axis accelerometer. It's a ring type one, coming in Q3 2021, is expected quite soon then. It features a through-hole mount for 360 degrees orientation. The unit has the unit feature to be able to work stably, constantly at 900 Celsius or 1650 Fahrenheit. That's pretty unique. Okay, website surfing. Okay, this is to orient yourself into the Meggitt website. It's quite easy, and it's not that difficult. We have to point when on the web page on the upper menu, and point to the product and service menu. Reach out the sensor. Well, it's not really visible here, but the sensor part here down, where you have listed accelerometer and pressure sensors. In this case, you are opening to different sub pages, in which one you can scroll down for the vibration and acceleration and vibration one. You can scroll down to extreme high temperature, and then reach the quality documentation of our unit, the reach, and so on. Then the data sheet available at the moment on the website. Not every model is listed there because sometimes we do not want to share or to disclose many information. Meggitt dynamic pressure sensor selection. While we are here, we can go down to high temperature dynamic pressure transducers. Again, quality documentation and available datasheet. They are reachable quite easily. Again, all right, webinar takeaways. So what I wanted to actually have you to consider and to bring home today after this little webinar is that Meggitt has the highest tempered couple accelerometer so far. It's a feature which is currently unmatched on the market. Soon we will have another one capable for 900 Celsius. Every delivery unit is a result of more than 50 years of experience and thousands of measurement channels installed and still in use. So that's the main point because of the good reliability of the unit. Using our unit and our RCC, it's almost possible to double the available bandwidth of a measurement channel. We have to consider all the time when we are working in high temperature environment. Probably the audience knows better than me. We have to consider the change in inner impedance or the inner resistance of the measurement chain. That is always occurring because the crystal impedance is dropping at high temperature. Then the use of flexible cables, so our 3076 and 3076A, is making installations much easier, cable routing comfortable, and engineer's life easier, I would say. And then before going to question and answer, just to remember you guys that will be in September at the symposium of the aerospace testing. So if we want to meet in person, finally after this terrible year, we can meet over there. And I think it's over to you, Ben. Thank you very much.
Thanks, Massimo, and thanks for mentioning the symposium. You're right. I'm really looking forward to an actual physical event. These are great, but we all enjoy the actual physical events a lot more, I think. I'm really impressed by that. There was a point in that presentation where you corrected yourself and you were saying you called one of the operating temperatures, the temperatures they can operate in, as incredible, and then said, "Oh, actually," but I think it is pretty incredible. I mean, some of these devices are hundreds and hundreds, up to 900 degrees C. You said some of the new sensors. So it's an amazing achievement that and without these devices, engines wouldn't be possible, would they? Right? You would aerospace engines. They needed. They're integral to the system. So yeah. You obviously sell a lot of them as well. I'm just wondering what's the general availability of these units. Do they have a long lead time? Do people have to wait a long time for them?
Well, yes and no. Depends on the type of units. I mean, we do have usually a production programming and manufacturing, let's say, idea. I mean, we know what to expect according to historical data, and anyway, we also always provide some backup units in case of necessity. So we try to keep. I mean, we know that the crystal preparation takes longer. The baking and all the tests, everything, but we try to be ready and in case of occurring requests. So depends on the unit anyway.
Okay, great. And just another quick question from my part. I mean, please do, anyone watching, I invite you to submit questions. I see John Chase has submitted several, which is great. John, I'll get to these. I just want to ask the expert one more question. So is there a signal conditioner that's available for differential units?
This is in the pipeline. I mean, we are designing it, differential charge converter. So far, we are not there yet. So we are using our sister company solution, Meggitt Fribourg, Meggitt SA, which is providing the IPC 707, and it's perfect for most of our application.
Okay, thanks. That's interesting. Great. I'll just ask some of these questions then from John here. I'll start at the top. There's several here. Massimo, I mean, can you explain? John asks, can you explain how the vibration compensation stack works on the high temperature dynamic pressure sensors? Can you?
Well, basically, it's an accelerometer. It's an accelerometer which is working in a counterphase to the unit itself. So it's canceling the vibration that it gets. This is very briefly. I cannot go into details.
Okay. And next he asks, do you have a converter that can provide a 4 to 20 MA output from the charge amps on the high temperature products?
No. It's not one solution. It's not a solution.
Right. What OEMs use your high temperature accelerations and pressure sensors? I'm not sure if you want to answer that, do you? You don't have to.
Not really. Well,
all of the obvious ones, I guess.
I mean, customers will not really in two hands probably, but you know, gas turbine manufacturers, if we refer to gas turbines manufacturers, are now rather few. So, well-known companies.
Yeah, exactly. Yeah. Okay. All right. And just I guess a kind of general question about, what kinds of applications are suitable for the 6244 unit?
This is interesting. Well, general high temperature, I would say no. The 62440 should be, I guess, the single axe 900 Celsius. So probably some rocket components, some engine components, very high temperature on exhaust close by the the compressor as well, I guess. I mean, It's just a guess.
I actually have just one other question, really. You mentioned the units that are coming out later this year with some really high temperatures that they can operate at some really high temperatures. The last one, 900 degrees, right? I mean, what kind of applications are you looking at there for them? I mean, who do you expect to buy those?
This is the same question as before.
Yeah,
I mean,
you don't want to say. That's fine. That's fine. I'm putting you on the spot.
A business secret.
Okay, that's good. Well, I can see now that we don't have any more questions in, and I'm quite satisfied with that as well, Massimo. I don't know if there's anything else that you'd like to add. I mean, the recording will be available to download and view again after the event. So I'd encourage anyone, to do that if they want to review. We got one more from John. Can you see that one, Massimo? Do you want to take that one, or?
I don't see it actually.
If you click the Q&A, you'll see it.
Yeah, I am in there. You will develop the external amplifier for this.
I feel comfortable.
No, actually not. I mean, we are providing. I mean, this is a single-ended unit as well, so we will have one inline charge converter as well. The 1772 will be a specific dash number. We are fulfilling and completing the offering of these charge converters this year. I mean, they are all in design, so we'll be launching them soon. Of course, we want to provide the sensor, we want to provide the conditioner, because complete solution is much better.
Okay, great. All right. Well, thank you again, Massimo, for your time. It's an interesting presentation. It's a very interesting area. So, and thank you everybody for tuning in and watching live. And I hope you enjoy the rest of your day. Great. Thank you.
Thank you, Ben. Thank you, everyone.